Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So we're going to start off by multiplying this 5 by -5 to remove it. And so we're going to have x squared plus 24x minus 25. Whenever we go to factor, we have to make sure to replace the 5. And the two numbers we want to use are positive 25 and -1. And this first set we'll divide by 5. So we're going to have x plus 5 and then 5x minus 1. And so that would be your answer for your factoring. For the math knowledge question, it says the second term in a sequence is 12. So we don't know the first term. We know the second term is 12 and the third term is 6. And then we want to find the first term. And it says in this sequence, consecutive terms differ by the same amount. So the difference between these two, we subtracted 6. So to go from this number here, we're going to subtract 6 and we get to 12. So if you add 6 to 12, you get 18. And so that would be the first term in your sequence. So today we're looking at lesson 73, applying trig, angles of elevation and depression. So hopefully you'll understand your angles of elevation and depression after this lesson. An angle of elevation is the angle formed by a horizontal line and the line of sight to a point above. So if you look at your picture, you have your horizontal line here, and then he takes his eyes and he elevates, he looks up, and this is the angle of elevation right here. The angle of depression is an angle formed by a horizontal line and the line of sight to a point below. So here's our horizontal line. You take your eyes and you look down. Think about when you're depressed, or if someone is depressed, they're going to take their head and they're going to turn down. And the angle that is formed between the horizontal line and where their eyes are now looking is the angle of depression. The horizontal lines that are used to measure the angles of elevation and depression are parallel. So your angle of elevation and angle of depression are actually congruent because they are alternate interior angles. So angles 1 and angles 2 are congruent here. And angle 1 is your angle of depression. Angle 2 is your angle of elevation. But whatever the two angles measure, they are going to have to be congruent. So look in here. The angle of elevation from someone standing on the ground to an apartment balcony 40 feet above the ground is 42.6. How far is the person from the balcony, and how far is the person from the building? Well, the person is over here, and the balcony is up here. And so that's the length that we're looking for part A. So we're going to have to use either sine, cosine, or tangent. On this one, we have opposite and hypotenuse. So that's the sine. So we're going to do the sine of 42.6 and then equals 40 over A. And then we multiply both sides by A. And so we have A sine of 42.6 equals 40. And then we divide both sides by the sine of 42.6. And so then you're going to divide 40 divided by sine of 42.6 with your calculator. And I'm going to round to the nearest tenth. And so that's what you should get for how far they are from the balcony. 59.1 feet. For part B, we're going to go from the person to the building. This is the distance that we are looking for there. And so on this one, we have the opposite and we have the adjacent, which means we're going to have to use tangent. So the tangent of 42.6 is going to be opposite, which is 40, and then over adjacent, which is b. So we multiply both sides by b, and we have b tangent of 42.6 equals 40. And so divide both sides by tangent of 42.6. And so you're going to plug 40 divided by tangent of 42.6 into your calculator. And you should get 43.5 feet for that one. Okay. Looking at the next example, we have Lookout Point has an elevation of 3,400 feet above sea level. The angle of depression from Lookout Point to the base is 28.4 degrees. We want to find the distance from Lookout Point down to the base camp. So we're looking for that distance there. We can make a triangle like this. And so this angle here is a right angle. We are wanting to find this distance here. We know that the height is 3,400 because this length right here is the same as this length over here. Those heights are the same. And so on this one, we have the opposite and the hypotenuse. So that means that we are going to use the sine. So the sine of 28.4 degrees is going to be 3,400 over x. So we multiply both sides by x, and we get x sine of 28.4 equals 3,400. And so if you divide by the sine of 28.4, you're going to have 3,400 divided by sine of 28.4. And so you should get 7,148.5 feet. Okay, so hopefully you understand how to do that example. Looking at the next example, we've got Arnold, Cindy, and Betty. Those are represented by A, B, and C. And we want to know how far is it from Arnold's to Betty's. So going from A to B. So from A to B. And I'm going to draw a triangle here. And the angle of elevation is 24 degrees. And we want to know how far is it from Arnold to Betty. So we're looking for the hypotenuse here. What is, well, I'll use an A because it's part A that we're doing. So what is the length of the hypotenuse? Well, we know that this side length here is 450, the height. The elevation between the two is 450. They give us the height. So we're going to use sine because we have the opposite and the hypotenuse. So the sine of 24 equals 450 over A. So multiply both sides by A, and you have A sine of 24 equals 450. And so if you want to solve for A, you're going to divide by the sine of 24. So A equals 450 over the sine of 24 degrees. And so you've got to plug that into your calculator. and you should get 1,106.4 feet. Okay, so that'd be your part A. For part B, the angle of elevation from Arnold's to Cindy, so from here to here, is 28 degrees. So if I draw my new triangle, this angle down here is going to be 28 degrees. And we want to know the distance of the hypotenuse again. And we know the height is 570. So we're again going to use sine. The sine of 28 is 570 over your hypotenuse, which is b. So you're going to say b sine of 28 equals 570. And then you're going to divide by the sine of 28. So b is going to be 570 divided by the sine of 28 degrees. And so if you plug that into your calculator, you should get 1,214.1 feet. 1,214.1 and then feet. Okay? So hopefully that helps you with that example. Looking at the next example, a bear paces 80 yards from an oak tree, then finds the angle of elevation to the top of the tree to be 37.3 feet. Find the height of the tree in feet. And it asks us to include a figure with our solution. So we want to draw a picture. We've got a person and we've got a tree. So I'm going to draw my ground. There's my person. And there's my tree. We know that the distance between the person and the oak tree is 80 yards. And we want to find the height of the tree. So we are looking for the distance here. What is this height here? This is going to be a right angle, and we can connect the two to make a triangle, and we're going to have 37.3 degrees for our angle of elevation. And so we're looking for this one, so we're going to use tangent because we have opposite and adjacent. So the tangent of 37.3 is h over 80. So that means that 80 times the tangent of 37.3 equals your height. And so if you plug that into your calculator, you should get 60.94. And that's in yards because we measured 80 yards from the oak tree. But they say find the height of the tree in feet. So how do we convert yards to feet? You're just going to multiply your answer by 3. And so you should get 182.8 feet. Okay? If you want, you can convert this to feet first. You go ahead and say that that's 240 feet, and then you don't have to convert at the end. Doesn't really matter to me when you convert, but that's what you would do there. Okay, so now let's look at the practice problems. We have someone standing 300 feet away from a building, and the angle of elevation is 67. Find the height of the building to the nearest tenth of a foot. Or no, to the nearest foot, I'm sorry. So we are going to draw our building. We've got our building here. We're going to draw a person. And going from the person to the top of the building, the angle of elevation is 67 degrees. and the person is standing 300 feet away, and we want to know what the height is. So we're going to use tangent of 67 is h over 300. So multiply both sides by 300. And so if you plug that into your calculator, to the nearest foot, you should get 707 feet. Okay, looking at the next example, we have an angle of depression of 55 degrees, and they give us a height of 160. How far away is their house from the window? So their house is down here, and we are measuring from here. So we are looking for this value right there. We know that this height here is 160. So going from the top down is 160. And we're looking for the angle here. The side length here. Now, if you look at our triangle, the 55 isn't actually in our triangle. But what do you remember about this angle here and this angle? Remember that they are congruent because they're alternate interior angles. So I can use the sine, and I have my opposite over my hypotenuse. So the sine of 55 equals the opposite over the hypotenuse. So I have x sine of 55 degrees equals 160, and so then I have to divide by the sine of 55. And so if you plug that into your calculator and round to the nearest meter, you should get 195 meters. Okay? Looking at the next one, we want to draw a hot air balloon at an angle of elevation of 30 for Jocelyn, and for Anthony at an angle of elevation of 50 degrees. So I'm just going to draw a little hot air balloon, and then I've got the ground over here. They're standing on the same side of the balloon, and they told us the height of the balloon is 140. And then I've got one of them here, and one of them is over here. Now, one of them is at an angle of 30, and one's at an angle of 50. It doesn't matter where you put them if you don't know who is further away from the balloon. But if you look at the angles, this angle is going to be bigger than this angle over here, and so Jocelyn is going to end up being further away from the balloon. But if you don't know that, just draw two separate figures and then do the math to determine who is actually further from the balloon, I'm sorry. So we're going to have to figure out what is the distance of the hypotenuse for each of them. So we have the height here, and so we're going to use sine. So we're going to say the sine of 50 is 140 over A for Anthony. And so A sine of 50 equals 140. And so divide by sine of 50. You're going to have 140 over the sine of 50. And so your A should equal, you plug that into your calculator, 107.25. And then for Jocelyn, we're going to do the same thing. The sine of angle 30 is going to be 140 over J for Jocelyn. So J sine of 30 equals 140. And so J is going to be 140 over the sine of 30. And so if you plug that into your calculator, you're going to get 70. No, you're not going to get 70. You're going to end up getting 280. And for Anthony, I did it backwards in my calculator, using my calculator on my phone, and I pressed the wrong button. But for Anthony, you should actually get 182.76. So those should be your two values, 280 and then 182.76. Okay, and so it asks how far apart are they? So what we need to do is subtract to find the distance right here. And so if you subtract the two, you should get 97 feet, or 97 meters. And then it asks who is further away from the balloon, and Jocelyn is further away from the balloon. Okay. And I just realized that what I found was the hypotenuse, and so that doesn't tell me how far apart they are right here. I found how far they are from the balloon. In order to figure out how far they are apart, we actually would not want to use sine. We would want to use tangent here. So I used my values to find the hypotenuse, but that's not going to tell me how far apart the two people are. Since they are on this side here, that's the adjacent side. So we're going to have to use tangent. So we would do tangent of 50 equals 140 over A. And so if you solve for A, you're going to have A equals 140 over the tangent of 50. And so your A value is going to be 117.47. And then if you do the same thing for Jocelyn, tangent of 30 is 140 over J, and you solve for J, you're going to have 140 over the tangent of 30. And so you should get 242.49. And so then, to figure out how far apart they are, you subtract those two. And you end up getting 125 rounded to the nearest meter. I'm sorry, that's how you do that one. I misread it to begin with. So then it asks who's further away from the balloon. We just did the math a minute ago, and we found that Jocelyn was further from the balloon. You can also think about it logically. The closer you get to something, the higher your angle of elevation is going to be to look up to see the top of it. And so since Anthony has the bigger angle, he's going to have to be closer than Jocelyn. So as you get closer to something, your head has to look further and further up in order to see it. And so that's how we know that Jocelyn is further away from the building, from the balloon. Okay, looking at this example. A surveyor on the top of Blake Hill measures an angle of depression of 16 degrees, and the height of Blake Hill is 400 and the height of Pike Peak is 300. What's the distance between the hilltops to the nearest meter? So it's wanting us to find the distance from here to here. We know that this distance right here is 100 because that's the difference in elevation of the two. And so we have a right triangle here, and we can use the sine of 16, and we would get 100 over x. So then multiply both sides by x, and you'd have x sine of 16 equals 100. So then divide by sine of 16, and you'll have 100 over the sine of 16. And if you plug that in, you should get 362.7955. It says to the nearest meter, so that'd be 363 meters. So that would be the distance between the hilltops. Looking at the challenge question, it tells us the angle of repose is a property of granular materials such as salt, sand, gravel. You can also think of flour, sugar, baking soda, cornstarch, cornmeal, anything like that. It's the maximum angle of a stable slope when the particles are poured into a cone-shaped pile on a horizontal surface. So we want to find the angle of repose. So we are looking for this angle here for a particle height of 8.2, and it's 28.6 meters in diameter. So if this is to the center, that means it's the radius, which is going to be 14.3. And so we're looking for the angle. So we're going to be using tangent because we have the opposite and the adjacent. So I'm going to set up tangent of my angle of repose is going to be 8.2 over 14.3. Now this is new. We actually haven't, or not, it's new for this year. We did do it last year, but we haven't actually done where we solve for an angle this year. So what you have to do to solve for your angle, you're going to rewrite it as the angle equals the tangent inverse of 8.2 over 14.3. And so you plug this into your calculator. The way that you do that, somewhere near where you found tangent, there should be tangent inverse, tangent to the -1. So some of y'all may have to hit second tangent to get that. Some of y'all may just have to hit a right arrow to get to it. But you'll plug that into your calculator, and then you're going to do 8.2. Don't try and use your fraction button. Do divide by, and then 14.3. And so if you do that, you should get 29.83 degrees. And so that's how you do the angle of repose for that particular pile. We will deal more with finding angles in trig at another time, but that's what you would do for this one. Okay, so your homework is 1 through 30, so you need to make sure that you do that tonight so that we can go over any questions you have.